Welcome back, everyone. Today we're going to be going inside of a 250 gigabyte portable hard drive to salvage out parts. To get inside, I'm using a plastic pry bar used to open cell phones to get at the battery. The hard drive is an aluminum casing held in place with adhesive. It comes off quite easily once you get inside. The plastic is also around the outside. Once inside, you'll notice these rubber coverings on screws which help with shock absorption. Once removed, the steel housing easily slides off. On the hard drive itself, there's a controller board with a tiny little LED light sticking out. The board itself is quite exciting to me because it will actually convert between the hard drive jack and a USB port. Let's take a closer look at that. On one end, you have the controller that does the conversion, the pins for the hard drive, and on the opposite side, the pin for the USB. I hope to reuse this later, but I'm concerned about power consumption. And then the controller for the hard drive itself is also easily removed. You might be interested in this rectifier. It's used to quickly change voltages. It heats up pretty quickly. In addition to that is this memory chip over here. The data sheet on it's about 50 pages long, but apparently it's a common component. I wasn't able to find out what this chip was for. There's a heat pad used to disperse some of the heat from the rectifier. That's a nice thing to have for later. The aluminum casing for the hard drive has a dampening pad. On top of the hard drive, you'll notice there's a clamp which is held in place with a screw into the actual hard drive motor itself. This is the perfect device for clamping down a disk to spin. Maybe you want to use that for a gyroscope in the future. The hard drive platter is further secured in place with a piece of padding. The hard drive head is kept in place by this thin piece of plastic. I suspect it's used to keep the heads in line when it's at rest. The platter comes out easily. There's, in theory, cobalt in between the layers here, and that's what's used to store the magnetic information. The rest of it's aluminum. Unfortunately, the motor is actually glued to the case in this model. This is the famous magnet that everybody always talks about in hard drives. It's held in place by a piece of steel. There's actually two of them in there. This is a connector for the read head and the arm control. The arm itself rocks back and forth on a bearing. If you'll notice this black little arm here, it will lock the arm in place. And there it is. It's now locked, and it can't move forward. This locking mechanism is actually called a pawl, P-A-W-L, and it's used often in clockwork. So if you ever wanted a locking gear, this might be a good option to salvage from. And this is the arm up close. There's a controller on it. There's the bearing. And I can only imagine that this is a fairly strong magnetic coil. The coil is layers deep and will actually control how far in the head goes. No gears involved. This is the motor. Inside of the motor, you'll see 9 of the tiny little coils inside. And there's the leads that control it. If you're going to use this motor, you're going to want a motor controller, to actually take advantage of it, although this motor would be great for use in a gyroscope. On the inside of the motor, on the cap end, you'll notice a black magnetic ring all the way around, in addition to a central bearing. And it just fits in together easily. Just to demonstrate that this is a magnetic piece, it sticks to my screwdriver quite easily. So what am I taking away from this hard drive that I will use in future projects? Here's the hull. Although I'm not sure what I'm going to use it for, the disk platter is pretty cool. It's shiny at least. You ever wonder what 250 gigabytes of data weighs? There you go. This controller I'm going to try and use on a regular hard drive, and I'm going to see if it fries it or if I can actually extract data out of it. I am worried about the power constraints. The bearing from the arm is going to be useful in the future, I'm sure. The electromagnetic coil, I'm sure, will be also quite useful, which is, of course, calibrated to be used with these magnets. Evidently, these magnets are quite expensive, but I'm sure you can buy stronger ones for not that much money. The motor itself will be quite nice to have, including the metal clamp on top of it. The pad that will dissipate the heat, and the tiny little LED, which is great if you want to put a light into a little hole that's only about 1 millimeter in size. And lastly, I have the rubber caps and the metal screws that are used for impact resistance. That's all I got out of this hard drive, and a bunch of scrap aluminum which I'll melt down someday. Thanks for watching.